So this is our problem that we need to solve. We have a car whose mass is 2500 kilogram and speed is 20 meter per second. If we want to solve this problem, what we will say that we are given some data. Mass of car M is equal to 2500 kilogram and speed of car 20 meter per second. And we need to find something, that is to find kinetic energy of car EK. So the solution will be, because this is kinetic energy, this is mass, and this is speed. We use this equation. EK is equal to 1 by 2 m v squared. 1 by 2, mass is 2500 and speed is 20 and it's squared. So this will become equal to and 20 square is 400, and if you multiply these two terms you will get the energy of 500,000 joules. Joule is the unit of energy. Okay, in System International, joule is the unit of energy and kinetic energy will be 500,000 joule. So if a car has this much energy, then we can estimate how much energy is stored in its kinetic energy store. Just keep in mind, this is only the energy which is stored in its kinetic energy store. There is energy stored in its fuel in the form of chemical energy store, and also it is because the fuel is burning in it, so there will be energy stored in its thermal energy store, and then the car is on its tire from certain height from the ground, so it will also have potential energy stored in its gravitational potential energy stored. So it's a very complex system of different energy stores, but we are just looking at one store, that is kinetic energy store, and how much energy is stored in that particular store is 500,000 joules. Okay. The given data, mass M is 20 kilograms, and we got height h which is 50 meter, and we got g which is 9.8 meter per second square, and we need to find gravitational potential energy. Eg is equal to to find. Okay. So Eg will become mgh. Eg is equal to, mass is now 20, g is 9.8, and height is 50. So is 1000 times 9.8, and it will become equal to 9,800. Okay, and what is the unit of energy? It's joule. So we can find potential energy by this technique. Gravitational potential energy, or how much energy in the gravitational potential energy store is, we can find by using this technique. So again, we got spring constant, that is K, we got stretching, which is E, and now what we need to find is elastic potential energy. So spring constant K is equal to 3000 Newton per meter, and what I would say is distance or length E is equal to 0.006 meter, and to find is elastic potential energy EE. So elastic potential energy is 1 by 2 K E square. 1 by 2 is 3000 multiplied by 0.006 squared. So 0.006 times 0.006, 6 are 36, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So this is the number that we get from the square divided by 2. So this will become equal to 1500 multiplied by 0.000036, 0.054. So we get 0.054 joule of energy.